So did they give you guys like a scope for the exam? I'm sorry, did they give you guys a scope for the trial exam?
They just said you have to study everything, so.
So do you know all the chapters? Because I think it's gonna be a bit difficult if I just say everything, but I'm not sure about all the chapters.
It's everything, so all the chapters.
Sorry, I mean the names of the chapters because I'm just saying organic chemistry because of the equations that I see in the particular question. I'm not gonna say like I'm 100% sure that it is organic chemistry. But let's just do it like this. This question two is organic chemistry. As you can see, like they even tell you that you have organic compounds. So in organic chemistry, I'm just gonna give you like some stuff that you're gonna have to know. So the first thing you need to know is the general the general equation. I think it's general equation or general formula of of the of the group. Yeah, of the group, because you're gonna have I think alkanes alkanes, yeah. Then you're gonna have alkenes, you're gonna have um alkynes, I think. Then you're gonna have aldehydes, sorry, and ketones and alcohols. So first thing you're gonna have to know is the general formula for these groups. I'm pretty sure they for example, I think for alkanes is something like CnH I think it's N plus 2, because for methane it's like C 1 carbon, it's gonna be mesh 2. Four hydrogens. So let me get an eraser here. So the amount, undo what I did, undo. 1 carbon, three hydrogen, and when it's gonna be 2 carbons, it's gonna be 6 hydrogen. I think it was 2N. Yeah, I think yeah, this was it. So for the alkanes, you have this general formula. So did they show this to you guys? So,
Yes, sir.
okay. Just, nah, man, why does this thing keep erasing itself? Yeah. Anyway, so the first thing you're gonna have to know is the general formula, and the second thing is the substituents. Yeah, basically substitutes. So you have to know that when you're changing an alkane, let's say methane to an alkene. Now you can't change methane to an alkene because it requires a double bond. So let's just say um let me clear some of this space uh, down here. Yeah. Uh, bring that back, bring that back, bring that back, bring that back. So let's say you wanna change um ethanol, ethane, C2H6 to an alkene or an alkyne. So firstly, let's change it to an alkene. So it's gonna change from C2H6 to C, and now we're gonna have a double bond between the two carbon atoms. So it's gonna be 1, 2, 1, 2. So you're gonna have your hydrogen there and your hydrogen there. So from this, you can see that the equation it changed from CnH2 H2n plus 2 to number of carbons multiplied and 2 is going to be 2n. These two, this is no longer there, so it's gonna become CnH2n. So that's the general formula for alkenes. So do you understand that far?
Yes, sir.
So now that we know about alkenes, we're gonna change it from an alkene to an alkyne. So it's basically the same thing. It's gonna change from C2H6, and now it's gonna have a triple bond here. So this hydrogen and this hydrogen will no longer be there. So now from this you can see that the formula is no longer 2H, it's just CnHn, because the number of carbons is equal to the number of of hydrogen. But anyway, that's only for ethane. When you go from ethane to propane, butane, and all those things, it's gonna change as well. the number of hydrogen is gonna change, because for ethane it's only gonna be two carbon. For ethane, when it's an alkyne, sorry, it's only gonna be two carbons and two hydrogens. But for, let's say, propane, that's C3H8, C3H8. It's gonna be something like, so they understand it now. You understand how I changed from propane to propine, or yeah, I think it's propine or something like that, because the in at the end is gonna change to yin. I think, yeah, it's gonna change to yin. So basically you need to understand the form the general equations. You need to know what you need to know what substitute is replaced in order to get in order to get um an alcohol, a ketone, and aldehyde. So just from this, I showed you for an alkene and alkyne. So do you know the general formula for like aldehydes, ketones, and alcohols and all that stuff? Sorry, can you hear me?
Yes, sir.
I was asking about the general formulas. Like, do you know them, or like, because I wanna know how much information I should give you, and where I can help you, because chemistry has a lot of work. So I just wanna know where you're familiar and where you're not familiar.
I know the basic search, just when it gets to the questions, then I struggle a bit.
Oh, so you like, can we do like maybe one or two questions on organic chemistry?
Yes, sir.
Okay. If it's like that, then it's fine. Then let me just erase this. So here we have six organic compounds. So basically, what I usually do when I see I see this, I try to categorize all the compounds, so that I know that this is an acid, this is an alcohol, this is an aldehyde, this is a ketone. So firstly, we have methanoic acid, which is a carboxylic acid. So this is a carboxylic acid. Then we have C10H22. If you remember from that general formula, it's CnH2n plus 2. So from this equation, Cn 10 times 2, 20 plus 2, 22. You know that this is an alkene. So this is an alkene. I'm sorry, alkane, man. Sorry. It's an alkane. And we're gonna look at this. You know that for an alcohol, you have an OH at the end. So this is an alcohol. Alcohol. It's an alcohol. Then pentanol. I think just from my memory, I think the ones that end with pentagon with nal or something like that, or al, if I remember well, they are ketones, if not aldehydes. So it's an aldehyde, no? Yeah. Yeah. So yeah, I'm sorry. So yeah, the aldehydes. So this is an aldehyde. Then from here, C3. Let me just draw this on the side so I can see something. This is connected to 2. So basically, since like this is a very complex structure, I'm just gonna draw it here and see, so I can find out what it is. So it's C 1. It's 1, 2, 3. So 3 carbons attached to 1 carbon that is attached to bromine, which is attached to another carbon. This is hydrogen here, hydrogen there, hydrogen here, hydrogen there. Then there's a carbon here. There's a bromine here. 1 carbon and another carbon. So basically, in this particular case, do you know the names of the groups on the periodic table of the group that bromine belongs to? Let's just search the group name real quick. Group 15, group 17. Yeah, so since bromine is a halogen, so this is gonna be a haloalkane. I don't know if you guys call them haloalkanes or you have a different name for them, but haloalkanes are basically alkanes with halogens in the chain. So it's a haloalkane. So this from this structure, you know that this represents a ketone. Just from the data that that they presented to you, like in your first term, you just know that the general ketone. Says 10 minutes left. So this is a ketone. So basically, if you know the general formulas, you'll be able to identify um all these organic compounds that are here. Let me just erase this. So now I think we can go on to question 1. So in this situation, since like I'm gonna try to help you, I'm gonna ask you the questions and see if you can identify them rather than me just giving you the actual answers. Would that work?
Yes, sir.
Yeah, so we're just gonna go to the first question. They say write down the letters that represent the following. So from this, I think the ketone I already gave it to you, so it's already F. But the two compounds that are functional isomers. So which one do you think it's actually two of them? So which ones do you think are functional isomers? One, two, three, four, five.
Is it B and F, sir?
Sorry?
B and F.
Yeah, it's actually B and F because aldehydes like in ketones, they basically have the same they basically have the same formula. It's just that the placement of the oxygen changes the function of the isomer. So yeah, it is gonna be B and F. So a hydrocarbon.
Hydrocarbon. C, sir.
C. An alkane.
Yes, sir.
Oh, are you sure?
Yes, sir.
No, I just wanted to check because so you're right, but you never know because some people, like, when you ask them if they're sure, they usually change their answer, but at least like you stuck to it. Let me just check this. So let me just erase this now. So we're gonna go to 2.2, and they say write down for compound D, write down the homogeneous series to which it belongs to. Yo, man, why is this mouse so sensitive? So we're gonna talk about D, and they say write down the homogeneous series which it belongs to.
Hello again, sir.
It's basically, so basically, like, if you can identify them, the next answers are gonna be easy because I identify them, and now like everything's just going nicely. Now here comes the tricky part. I'm gonna draw it. I'm gonna draw it on the side while you determine the UPEC name on your side. Is that fine?
Yes, sir.
So the only one like the UPEC name. So it's gonna be something like this. 3 carbons attached to a fourth one, attached to a fifth one. This one is attached to another carbon, and another carbon. Hydrogen, 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 hydrogen. Hydrogen and one more hydrogen. Yeah, so from this, what do you think this can be? 1, 2, 3, 4, 5.
So is it 3,5 dibromooctane?
So you said octane. 1, 2, 3, 4, 5, 6, 7, 8. 3, 5. 1, 2, 3, 4, 5. Dibromo octane. The one in this one connected to. Yeah, yeah. Because if you look at it, it's an alkane with two halogens, so it's gonna be dibromo. So do you remember how to write the UPEC names?
Yes, sir.
So you know that there's no spaces in between.
Yes, sir.
Okay. As long as like you know how to write the UPEC names and all that stuff, I think it's mostly gonna be easy. So I'm gonna stop recording now.